We will have our lesson on friction. And again, a friction is a kind of a force that moves in opposite direction to the motion of a body. No? So if we are to illustrate a body, for example, like this box, no? So if this box moves to the right, no? So if you happen to pull this to the right, no? So you can either use a string, a cable, no, to pull this to the right side, no? Now the frictional force will try to prevent that motion, no? So the frictional force will go to the left, no? So it's in the opposite direction, no? And probably just like this person that's walking or running, no? If uh, if the shoes, no, happens to move forward, then uh, the floor or the frictional force will move in the other direction. No? Now, one good thing about friction is that it allows us to undergo locomotion. No? It allows us to transfer, to travel. No? If there's no friction between the shoes and the floor or the ground, no, then in no way can you walk, no, or can cover certain distances. No? Now, what is in between the surface? No, anong ara sa surface? So if this is the floor, no, and this is the crate or the box, in between them, no, the area that is in contact, we notice that it is a rugged surface, no. So this jagged edges, no, cause the object to, no, to not really, no, move or freely, no, slide, no. So every surface has irregularities, no, no matter how smooth it is, no, despite the fact that you will use a tile, no. If you put together two tiled objects, you'll notice that they still have these jagged edges, no. So once these edges comes in contact, no, that's where the friction comes in, no? So frictional force plays an important role, no, in our motion of objects, or the thing we call as mechanics, no. Friction is a contact force, no. So for you to have friction, the two objects has to come in contact, no. So if you suspend the object in air, then there's no friction there, no. So friction is a kind of a contact force, no. What are forces that are considered non-contact forces? No, gravity is one, no. Despite the fact that you are not, no, in touch with the ground, no, or the earth, you are being attracted by the action of gravity. Magnetic force is also non-contact, no? But friction, it is considered as a contact force. You have to really, no, put objects together, no, side by side for you to have frictional force. Now look at this, no. So if you pull this to the right, no, the frictional force, which is indicated by small letter F, no, is now going to the left side. Usually, frictional force is indicated by a small letter F. If you notice that if there's now a small letter K beside it, no, then we call this kinetic friction. No? Kinetic friction is present, no, when the object is already sliding. No? When it is not sliding, we call the frictional force there a static friction. No? So there are several kinds of friction. No? One which is at rest. When bodies are at rest, no, we call it static. And when it is moving, we call it kinetic friction. No? So again, one definition of friction is that it is a force that opposes the relative motion of the body. No? So if the body, no, if you change the direction of the pull here, going left this time, no, if you try to pull this to the left, then friction will reverse its direction. It will now go to the right side. No? It is, again, moving relative to the motion of the body. No? Now, what are advantages of motion? Now, if it were not for, what are advantages of friction? If it were not for friction, no, then we are not able to have locomotion. No? It is very difficult to walk. It is very difficult to roll in your bed, no, if there is no friction. No? Now, number two, in starting a car, no, from rest. No? So you will probably, no, engage the ignition switch. No? So again, you have to overcome friction and again, make it move. No? When a car turns around a curve, no? So if there's no friction here, then it will not prevent the car from skidding, no, or going out of the road. No? So some roads usually, to prevent, the skidding of the car, the road is banked. No? There is a slope there that is what they call, banking of the road, no, so that the car can make a safe, turn around a curve. No? So those are things that they add on the road to increase the frictional force. No? Another advantage, no, it is needed in motors, no, that are driven by belts. No? So if there's no friction here, then you cannot drive this other gear. No? So if you consider it as a gear, no? So this is our belt, then we need to drive the other material, no? The other gear, no? or wheel. No? So next, number 5, it is needed in holding objects by means of nails or screws. No? So if you fasten two objects together, then it will hold because there is friction, no, that is present between the objects that are in contact. Now, disadvantages of friction when it is too much also, no? So it causes a fast, no, a wearing out and tearing out of parts. No? So this is a piston of an engine. To be able to keep this, no, so that you will not be replacing it time and again, then you have to put, no, a certain oil, an engine oil, a specific engine oil in the engine. No? So these are parts that are moving and heat is produced, therefore it eventually, disintegrates or it gets damaged. No? Number 2, it increases the effort, no, necessary to operate any kind of mechanical devices and therefore reduce the efficiency of machines. No? So if there are frictions, no, on the wheel, on the tire, no, then you'll have difficulty, no, driving this bicycle. No? Okay, so if this is a lawn mower, if there's so much friction there, then you will spend your energy, overcoming friction, no, rather than not trimming the lawn. No? So if there's too much friction, so you have to see to it that this one, no, works well. So you minimize friction there. No? It produces heat, no, by converting mechanical energy into heat. No? So when things are in contact, then you notice that it is heating up. No? So friction is produced, no, when things are rubbed together. Now, how do we increase friction? No? So if we need, no, to make the road safe, then we don't make it very, very smooth. No? So we roughen the surface, or we make the surface more rough. No? In case of in places where there's snow, they use snow chain, or again, tire chain, no, to increase the friction on the road, no, and the tire. They use rubber materials, no, between the road and the tire and the road, no. So to the combination of the concrete, no, and the rubber tire, no, has the highest amount of friction. No? Now, some shoes also have spikes, no, like that in golf. No, I don't know what do you call that. The shoes used by those who play golf or those who play football. No, so there are studs, no, sa sapatos. So again, no, adding spikes also increases the degree of the friction, no, that are in contact. No? So when there's also not too much friction, then how do we reduce it? No, so for engines, no, like gears, we put engine oil. No, so oil is a lubricant. Water is likewise a lubricant. There's also this thing we call as grease. No, the grease is used by mechanics, no, to also lessen the friction between mechanical or metal parts. No. So if you smoothen the surface also, no, remove the rough edges there, you will also reduce the friction. No? Using tiled floors, no, rather than using concrete directly. No? So we improve, no, or reduce the friction in that way. No? For patients who cannot dispose no their body waste, no. So they use suppositories, no. So that no if you have a constipated no you have not discharged no body materials, no waste materials in your body for so long, and you get constipated, and sometimes they use suppositories, no. Now next, we have ball bearings and roller bearings. This is an example of a ball bearing, no? So this is used in parts of cars that rotates, no? So this one also reduces the friction that are in contact, no, between engine parts, no. Now there are 5 factors that supposedly we are to mention, but I believe no, there are only 3 that are crucial or important to us, no. And perhaps no, that's the one that we will just tackle on, no, for today. So the first factor that probably affects friction is the nature of the surface, no? So when we say nature of the surface, if we have wood, no, if we have metals, if we have rubber, no, materials, then their degree of friction changes, no. So some materials offer more friction, other materials offer less friction. So the kind or the nature of the surface basically, no, affects the amount of the friction, no? Or if the surface is rough, or if it is smooth, no, then friction will be different, no. Now again, there's a kind of friction called kinetic friction. Kinetic friction is indicated by Fk, no? And this is the kind of friction when the body is already sliding, no. Now, but before the body slides, no, there is still friction present, no. If the body is at rest, then we call the friction there as static, no. And we will mention it no later, no. Now, friction is caused no by the interlocking of irregularities between the 2 surfaces that are in contact, no. So again, no, so if you will magnify these contact parts, no, of this object at the top of this wood and the wood, no, you'll notice that it is smooth. It is not smooth, no. It's very rough, no, on a magnified version, no? Now these parts that are very rugged will now interlock, no, with the other surface, therefore, no, offering, no, frictional force, no. So again, now when you move this to the right, friction will go in the opposite direction, no? So again, no, the kind of surface affects the degree of friction, no? Okay, which is easier to pull, no? So pulling is when you use a cable, so just like tension, no? You pull it, no? When you push, then you apply a compressive force probably, no? Which is easier to push or pull, a box on a smooth surface or the one which is on a rough surface, no? So obviously, no, the one on the rough surface will offer, no, greater frictional force, no? The smoother one will offer less, no? Now, another factor that we will mention also is when the body is either at rest or the body is already in motion, no? Now, this is a familiar image, no, where people, no, try to push the car. Probably the car won't start anymore, and you want to park it, no, properly. Or in the Philippines, no, when the car won't start, no, then they will try to make it start, no, or make it uh, para mag-andar siya, no, by pushing the car, no. So if we are going to push the car, no, if it starts from rest, you'll notice that you will require more people, no, from the condition where it is at rest, no. But you'll notice that once this car is already sliding, maybe it starts with 3 people pushing it, but once this is already sliding, maybe only 1 or 2, no, can still, no, keep it moving, no. You don't have to ask, no, more individuals once this is already moving, no. And we notice there that friction is affected, no, by the condition whether it is at rest or it is already in motion, no. Now they believe, no, that greater friction is present when the car was initially at rest, no. So frictional force that is called static friction, no? This is the kind of friction when the body is at rest. This is greater frictional force than when the body is already sliding, no? Now, if a body is at rest no, on a surface, a larger force is required to overcome that friction. No? And again, the friction when it is not moving is known as static friction. No? Now, if we compare that when the car is already sliding or moving, no, there would be less kinetic friction once this is already moving. No? So if we'll compare no, Fk no, or Fs, so static friction, guys, is bigger than kinetic friction. No? Now, there's another frictional force that they call as rolling friction. No? And we'll call it Fr. No? Among the three, rolling friction is the smallest. No? So again, no, Fs is our static friction. Our Fr is our, Fk no, is our kinetic friction. While Fr is our rolling friction. No? Rolling friction is present in bearings. No? So the bearing that we show earlier, no? So that is present in that material. No? But among the three, no, rolling friction is the least. No? So if you have moving parts, then you better consider no, maybe no, bearings, no, using bearings. No? So again, this is the second factor. No? So the state of the body affects its degree of friction. No? So static friction is known as frictional force no, when the body is at rest. No? Okay, another factor that we'll try to consider is known as our total normal pressure or total normal force. No? The total normal force, which we already mentioned before, is present when a box or a weight no, is pressed on a table. The table will create a reaction. No? So this reaction is known as the normal force. And usually if they are, if this one is placed flat on top of a table, N and W are simply equivalent. No? Now what they notice is that whenever the body of bigger weight is pressed on a table, its normal force also increases. No? Since again, N and W are directly proportional. No? Bigger weight usually indicates greater normal force. No? And whenever you drag, which one will offer a greater friction? When you drag a bigger mass or when you drag a smaller mass? No? So which one is easier to pull? No? So let's say we have a diagram here. No? So this is placed on a table. No? Which is easier to pull? No? Di nang masapos butungon. Ang gamay nga box or ang dako nga box? Guys, di nang masapos.
Ang gamay, sir.
Masapos siya nga butungon. No? So di nang mas dako friction. Which one has a bigger frictional force? Ang gamay nga box or ang dako nga box?
Ang dako nga box.
Ang dako.
Dako ang friction sa babaw. No? So again, now what factor affects the degree of friction there? No? Again, if there is weight, kung ang ini may weight, okay, ang iya weight B is weight 1. Okay, that's W1. We notice that because of that weight, may ara na siya karon nga reaction ang salog, no? And that reaction is known as the normal force, no? So the normal force, and again, for this object sa dalom, no? Di na yan ang mas dako nga normal force. Ang sa dalom or ang sa babaw. Again, N and N sub 2 na din. No? N sub 2 is due to our weight 2 also, no? So amo ni weight ni siya sang object 2, no? So di nang mas dako N2 if N and W are equal, no? So what can you say about the normal force, no? Ang ato normal force diri karon N1, no, will be greater than N2, no? Again, N and W are equivalent, no? So if this has bigger weight, then its normal force will be bigger, no? So we said also nga mas dako diyang friction. So we can actually, no, conclude that friction is, no, related, no, or probably equivalent to, no, our, no, normal force, no? Kay kung nagadako ang normal force, nagadako man ang frictional force, no? So ano ang value that will make them equivalent? Amo nang ginatawag naton nga mu, no? So mu, no, is known as the coefficient of friction, no? But you'll notice that normal force again and frictional force happens to be, no, directly proportional, no? So again, no, the nature of our equation. So if we'll remove the proportionality here, no, and change it to equality, no, then we have this equation eventually, no? So F sub k is equals to mu sub k times n. Again, mu is the coefficient of friction, no? So if it's moving, then we call the coefficient of friction as coefficient of kinetic friction. Now, usually the value of mu is between 1 and 0, no? It does not exceed more than 1, or it is not also negative, no? Now, the more rough is the surface, usually the value of mu gets closer to the value of 1, no? Kundo mas rough ang atong surface, no? Okay, so again, now we have the equation there, no? Okay, let's try this sample problem, no? A loaded box, no? So this box has contents. Its weight is around 600 Newton, no? And it is pulled along the level floor, no, with constant velocity. So the word constant velocity there is telling us that this is moving in uniform motion, no? So whenever it is moving in uniform motion, that is a crucial, no, concept, no? So if it's moving in uniform motion, so if v is constant, no, then its acceleration is eventually equal to 0, no? Now, according to Newton's second law, if the acceleration is 0, then the net force, no, since mass times acceleration ang net force, then the net force, no, if A is 0, then the net force will also be 0, no? So this is what happens when we are dealing with a body, no, that is traveling in constant, no, or in uniform motion, no? So a body in uniform motion, we have this, no, notation, no? So therefore, now if along the horizontal axis, guys, no, if along the horizontal axis, if we have, for example, no, if in the horizontal axis, if we have here, no, so along the x-axis, no, so of course we have there F, the applied force, no, and then F sub k, which is going left, no. If it is no, undergoing uniform motion, then these two values is equals to the net force, and the net force is equivalent to 0 eventually, no? So Fx is F minus Fk, and their difference, no? So since this is the one that causes the motion, it will just simply be equal to 0, no? Again, no, because of this condition. Now, if we will consider the vertical force, no? Ang ara naman niya sa vertical axis, on the vertical axis, Fy, no? We have for our vertical axis, no, our Fy is equal to n that goes up minus w that goes down. No? Since the body there does not move vertically, then that's also equals to 0. No? So this is the net force equals to 0, and this is indicating that this is at rest vertically. No? Now along the horizontal line, it is moving, but it is moving with constant velocity. Therefore, we can also say that the net force there is 0. No? Now, if the vertical force is equivalent to 0 na ang net force, then we can obviously say that N must be equal to W. No? Ang maniyatong condition dali, no? Okay, so from here, if our F minus Fk is 0, then therefore F, the applied force, is just equal to F sub K. No? Oh, sorry, no, there's no mu there. No? There's no M. So our value here is simply the applied force. The applied force is equal to Fk. No? And what is our value of Fk? No? Ano yung value natin sa Fk? No? So if F is equals to Fk, then we know that Fk is mu, no, times N. No? Mu times N. So we write mu. So this is the Greek symbol mu. No? So the value of mu was given to be 0.12, no, in a problem. No? So how much is the tension or the applied force? No? So this is our tension or applied force. So since this is equal merely to the kinetic friction, then our value now will simply be equals to 0.12, no? Times N. No? Our N is equals to the weight, no, which is equals to 600. Sorry, no, this must be 600, no, please. So how much is the value of 600 times 0.12? No? 600 times 0.12, muni ang aton nga 72, no, Newton. No? So again, the explanation why we have these equations over here is that, again, the horizontal and the vertical forces can be described to be either at rest or it is moving with uniform motion. No? Okay? Do you have a question? So this is now 72 Newton. No? So that's 600 times 0.12. No? Okay, do you have a question so far? Okay, let's move on now. Maybe there's another example here. No? What if there is an angle to the rope? No? So we have there a rope, no? And it is pulling the object with a given angle. No? So probably it is the same equation earlier. No? So again, if the rope in problem number 1 forms an angle of 30 degrees, no? So let us illustrate that problem. No? So maybe in the next illustration there's a diagram. So if we have here we are now exerting a force on this box, and the tension now forms an angle of 30 degrees. No? So with respect to this horizontal line, there is now an angle of 30 degrees over here. No? Okay, so I think I'll just use a whiteboard. No? So let me use a whiteboard. So let me draw our problem. So we have a box over here. This box again is being pulled by a force. Let's illustrate the force by an arrow. So this is our tension. So the tension here, T, forms an angle So if we have here now, so if this is our line, so we have sorry, no? So if this is our horizontal line, no? Let's just use this one. So if this horizontal line, no? There is an angle here equivalent to 30 degrees, no? In between, no? So this is forming an angle of 30 degrees, no? Now, if you recall, no, if a force is creating an angle, then it will produce no two different components. No, one of its component is a horizontal component, no, and then the other component of that force is a vertical component. No, so duwa na kabilog iya components. So we call the horizontal component as Tx, and the vertical component we call it as T sub y. Now we usually calculate the value of T sub x and T sub y in terms of the tension there as equivalent to T sine of 30 degrees. No? So you use your sine function. Our T sub x is in terms of cosine. No? So this is equals to T cosine of 30 degrees as well. No? So what are we looking for? No? So we are actually looking for still how much is this tension that is present on our box. No? Now, other things that are given. No? So if you drag this to the right, you'll notice now that frictional force will also move on the other direction. No? So it will, this one now will move to the left. No? So there is a frictional force that is going to the left. You can call this still as Fk. No? Fk basically is not really that big. No? Let's change the color of the text. No? So our F sub k is going left. Now other forces that are also present are, so what are other forces? We have one, the weight. Our weight is given to be 600. That's 600 Newton. And another force here that goes upward now, which reacts with the weight. So we call that force as N, normal force. No? Now again, N and W are equivalent. No? So again, we can divide our forces here in terms of those forces that are acting on the x-axis and those forces that are acting on the vertical axis or Fy. No? So what are horizontal forces here? No? One horizontal force is T sub x. No? T sub x is going right. We can now disregard, guys, no? This one. No? We can disregard that one because that's not basically horizontal or vertical. No? We transform it now in terms of Ty and T sub x no? By using the components. No? So again, no? T sub x goes right. No? And if we will complete this equation, we will be subtracting our frictional force here. No? So minus Fk that goes left. No? And that's it. No? There are only two forces horizontally. No? Now, if this one is moving in uniform motion, then again, they will have a total value equal to 0. No? So from this, now we will see that Tx is simply equivalent to Fk. No? So this is one equation, horizontal forces. Now, vertical forces on the other